video, we're just going to look at the first few powers of I, the imaginary constant. So we're just going to calculate the first few powers and highlight that there is a pattern. So I've just put in at the top here in this box a very important definition that I, by definition, is the number that when we square it we get -1. So it's the square root of -1. So I squared equals -1. With this single bit of information we can calculate any power of I, so we're just going to calculate the first few. So the example is to compute the first 5 powers of I, starting with I to the power 1. So the solution is, well, I to the power 1 is just I. So we treat the imaginary constant as a real number in certain ways, in that it follows, it's not a real number, it's an imaginary number, but it follows certain rules of real numbers. So any real number raised to the power 1 is just that number. So x to the power 1 is x. It's the same for I to the power 1 is I. So this one's easy. I squared is also easy. It's written in the box at the top. It's -1 by definition. What's I cubed? Well, I cubed is just I squared times I, because I times I times I. So I squared, we times it by I again, we get I cubed. But we know I squared is -1, we've just said that, so it's just -1 times I. So it's just minus I. Times something by -1, it's just the same as giving it a minus sign. Well, I've already had a minus sign, getting rid of its minus sign. So -1 times I, just a simpler way of writing that is -I. So if you think about what we're doing, then what we did there is we just multiplied the result from above, I squared, by I again, to get I cubed. And we can continue doing that. So I to the 4 is equal to I cubed times I. But we just said that I cubed is -I, so we get -I times I. So -I times I is -I squared. I times I is I squared, and we just have the minus of that. And we already know that I squared is -1, so we get -1, which is 1. So far, we've gone I, -1, -I, 1. You may be able to spot what's going to come next. So I to the power 5 is just I to the power 4 times I, same trick again. I to the power 4 though was just 1, so it's just 1 times I, which is just I. So we've gotten back to where we started, if you like. We started with I to the 1 is I, and now we've gotten back to I. We went through -1, -I, and 1 along the way. Let's just sum this up over here on the right of the screen. So we said that I to the 1 was I squared was -1, I cubed was I to the 4 was 1, and then I to the 5 is equal to I. And I'm just going to say ... The reason I'm saying that is because now we can see that this pattern is just going to repeat. If we did I to the 6, that's I to the 5 times I to the 5 is I, so it's just I times I, which is -1. It's exactly what we did when we did I squared. We did I times I. If we did I to the 7, that would just be -I, and then we get 1, and then I. So you see, it just goes round in this. Once we've gotten back to where we started, it will just go round like that forever. So we go I, -1, -I, 1, I, -1, I, 1, I, -1, I, -1, -I, 1, I, and so on. So any integer power of I, any whole power of I, is either going to be I, -1, -I, or 1. And when you know that, it's actually quite easy to calculate very high powers of I. You just have to use a few tricks, and we're going to see how to do that in the next video.